Hi, I'm Mr. Greta. I'm going to take you through graphing tangent functions. I'm going to try and do this quickly as possible. I'm going to ask you to stop a few times and do a couple calculations on your own to get some understanding. And at the end of the video, please fill out the form that's available for any suggestions on improving the video. Okay, so I'm going to talk about graphing tangent functions while trying not to go off on one. All right, before we begin, let's just look at the unit circle. Everything in trig really comes back to this, and this includes the tangent functions. This is a great unit circle, actually. I got it from www.geocities.worksheet. Just search these images. I like this one because it has the degrees and the radians right there. Okay, first of all, I'm just going to go over a couple different concepts. You don't need, for graphing, but you need to understand conceptually what's going on. The first is that the tangent x is equal to the sine x over cosine x. Okay? That means, if you recall, the sine is your y and your cosine is your x. So we can go through and find values that we're going to be graphing here for each radian measure just by dividing the y divided by x. So for instance, at 0, 0 divided by 1 is 0. Okay? 1/2 divided by the square root of 3 over 2 ends up being the square root of 3 over 3, okay? Which is roughly, I don't know, like 0.57 or something like that. Square root of 2 over 2 divided by the square root of 2 over 2 is just going to be 1. Okay, and the square root of 3 over 2 over 1/2 is going to be the square root of 3, which is roughly 1.7. And then here's where it gets interesting in tangent graphs. If I do 1 divided by 0, I can't divide anything by 0, and this is undefined, and you're going to have an asymptote at that spot. Okay? If you want, I would suggest stopping the camera and dividing these values, the y divided by the x, for the fourth quadrant, just so you get a feel for what's going on. Okay, welcome back to the video. All right, now, if I go down here, I just want to go and show you this one here is also, if you take -1 divided by 0, it's also undefined. And so really, what you want to do, and these other values I should point out are going to be negative because you have a negative divided by a positive, negative divided by a positive, but they're mirror images. Basically, they're the same absolute value as the values you have in the first quadrant. -1 instead of 1, and of course this is negative square root of 3 over 3. Okay. The period of a tangent function actually goes, unlike sine and cosine that start at 0, the period starts at negative pi over 2. Okay? And you go through these values and graph these values all the way up to positive pi over 2, which is a period of only pi. This is different than sine and cosine that have a period of 2 pi. Okay, so how does this all relate to a graph? Let's go ahead and graph first just the regular tan function, and then we're going to graph one that demonstrates all the other transformations you can do to the graph. Okay, I'd recommend using a straight edge. Set yourself up. Okay. So first of all, we said by looking at the unit circle, at negative pi over 2 and pi over 2, it's undefined. We're going to have some asymptotes. So I'm just going to start there. So here's negative pi over 2, and here's pi over 2, and here are my vertical asymptotes. Okay. We can also get the other values here. We get 0, 0. And I'm just going to do the easy values. I'm going to skip over these radicals because it's not going to matter. And you'll see us after we do a couple of these, you don't have to worry about, you're not plotting a whole bunch of points. So I'm just going to At pi over 4, I know it's going to be 1. Okay? So pi over 4 is halfway, and I know that we're going to be at 1. And then at negative pi over 4, I'm going to be at negative 1. So negative pi over 4, I'm going to be at negative 1. Okay? And then graphing this also just takes a little bit of knowledge of what the tangent graph looks like. It looks like this, basically, before you manipulate it. So we're going to come up this asymptote, pass through this value, come through the origin, and then up again to the asymptote. And that is not my best. That is pretty bad, actually. But just there you go. Okay. And this is why I'm not an art teacher. Okay, but you can look up on the internet or just in your book or something, a tangent graph basically looks like that. That's the basic graph. It shoots up towards the asymptotes.